Good morning, good afternoon, or good evening to you. We are Group 7 of Class A58, and today we will be presenting on polar climates, the polar areas, and how their climate affects their architecture. The following is the content of our presentation. First, we will begin with the introduction, followed by environmental conditions, and then the countries and regions under polar climates, and then climatic design, followed by conclusion. To provide a brief introduction on what the polar climate is, the polar climate consists of cool summers and even cooler winters. Therefore, it is characterized by frigid climates. Consequently, the land is treeless, covered in layers of ice, both permanent and semi-permanent, and has glaciers on its cold waters. The following is the content of our presentation. First, we will begin with the introduction, followed by environmental conditions, and then the countries and regions under polar climates, and then climatic design, followed by conclusion. In terms of location, the regions that surround Earth's north and south poles are considered the polar zones. The area of the south is known as Antarctica, while the area of the north is known as the Arctic. These regions cover about 20% of the Earth's surface, and these are all far from the Earth's equator. When it comes to the latitude of the North Pole is 90 degrees to the north, and the latitude of the South Pole is 90 degrees to the south. It is this way since the circumference of a sphere is 360 degrees. If you start counting degrees along a meridian, or the lines or dimensions that divide the Earth, you will reach 90 degrees at the North or South Pole. Beyond that, you just arrive back to the equator, so there's really no point in going beyond 90 degrees. In terms of its longitude, although longitude theoretically exists on every surface of the Earth, this becomes more and more undefined when it comes to the North and South Poles. The lines of longitude converge at the poles since they are at the very bottom of the sphere, or the planet. Therefore, it is quite difficult to assign a specific value to them. Therefore, the longitude for both poles are considered undefined. In terms of altitude, the North Pole is basically at sea level. Since the North is located within the Arctic Ocean, the sea ice is considered as a land mass that is not entirely solid in form, but rather just a frozen expanse of the water. Therefore, the North Pole does not have a significant elevation above sea level. On the other hand, unlike the North, the South Pole is situated on the continent of Antarctica, and the ice sheets that can be found there covering the continent are significantly much thicker, giving it a greater altitude when compared to the sea level. Therefore, it can be said that the altitude of the South Pole is approximately 2,835 meters or 9,300 feet above sea level. When it comes to temperatures, the average mean temperature of the north is 32 degrees Fahrenheit, while in the south it is negative 18 degrees Fahrenheit. The difference in temperature makes the south much colder due to its winds and mountainous terrain. On the other hand, the ocean surrounding the north makes it much warmer, given that water changes temperature, limiting the growth of ice. According to the Danish Meteorological Institute, the daily mean temperature of the north has been ranging from negative 30 degrees to 0 degrees, depending on the month and season of the year. On the other hand, according to The Economist, the daily average temperature has been getting warmer and warmer within the March 2022, reaching negative 20 uncharacteristically. It is important to note that getting accurate results on temperature patterns of the north and the south can prove to be extremely difficult, given that both areas have extreme patterns when it comes to their weather and climate. Now, when it comes to the relative humidity of both the polar regions, given that temperatures can become extremely low, dew point temperatures are also low, which is the temperature at which the air's water vapor could become liquid water. The air within the polar regions is usually around 80% saturated. Given this, relative humidity is quite high.
In polar climates, the primary form of precipitation is snow, due to the extremely cold temperatures. Precipitation level can vary based on the location and season within these regions. Generally, polar areas receive lower precipitation compared to the other climates, and most of it falls as a snow, contributing to the buildup of ice and snow cover in these regions. Precipitation rates can significantly differ across various regions. Generally, these areas receive lower precipitation compared to other climate zones. The annual precipitation can vary from minimal amount in certain polar regions to slightly higher levels in others, primarily falling as snow due to the persistent cold temperatures. The sky often displays a fascinating interplay of sunlight and cloud cover. During polar summers, there can be continuous daylight known as the midnight sun, while polar winters experiences extended periods of darkness termed as the polar night. Cloud cover can vary, but in colder months, clouds tend to trap heat, moderating temperature extremes and contributing to a relatively warmer environment. Wind speed can vary widely based on the specific location and time of the year. Generally, these regions experiences moderate to high wind speeds, particularly during storm or weather disturbances. However, determining an exact average rate for wind in polar climates is challenging due to the substantial variation across different polar zones. Regarding wind types, there is katabatic winds, a cold, dense air masses descending due to gravity, are common. Additionally, cyclonic winds associated with storms and weather systems can bring turbulent conditions and strong gusts to polar regions, shaping the weather dynamics of this extreme environment. Vegetation is typically scarce due to the severe environment characterized by extreme cold, permafrost, and brief growing season. Tundra vegetation such as mosses, lichens, dwarf shrubs, and hardy grasses predominates in these regions. Trees are rare, mainly found in slightly milder areas along the southern edges of the polar regions, where some small shrubs or stunted trees may grow. Overall, the plant life in polar climates is well adapted to withstand the harsh conditions prevalent in these areas.
The polar climate can be found very close or basically at the Earth's pole and is typified by exceptionally low temperatures. As previously mentioned, the Arctic and the Antarctica are the two primary polar areas, and these two nations have several areas that are affected by the polar climate. For the Arctic area, we have Canada, Yukon, the Northwest Territories, and Nunavut, Greenland in Denmark, Finland, Iceland, Norway, Russia, Sweden, Alaska in United States. We can conclude that the North is quite diverse in human settlements. Unlike the North, however, the South has no permanent human habitation, although it does have several research stations. To name a few, we have McMurdo Station, which is the largest run by the U.S., Palmer Station, Amundsen Scott Station, both by the U.S., Esperanza and Marambio bases, run by the Argentina, Scott Base, New Zealand, Vostok Station, Russia. In all of the mentioned areas, long cold winters are common in many, with several days far below freezing and even very low temperatures in certain places. Therefore, these regions are distinguished by substantial amount of snow and ice covered throughout the year. Consequently, the areas have ecosystems that are suited to the intense cold and are frequently the habitat of unusual and specialized plants and animals.
Designing shelters for polar climates involves strategic architectural choices to address extreme challenges of frigid temperatures. High thermal mass materials such as specialized insulation and double-glazed windows form a robust barrier against heat loss. These elements create well-insulated enclosures that retain warmth in the interior despite harsh external conditions. Compact architectural designs play a pivotal role, minimizing surface area exposure to the external environment. This not only reduces heat loss but also enhances overall energy efficiency. The spatial efficiency of these designs is crucial for optimizing resource and ensuring a snug interior environment for occupants. Elevated foundations are strategically employed to prevent permafrost disruption, a critical consideration in polar regions. This design choice ensures the stability of the structure and mitigates potential damage caused by thawing permafrost. Wind resistance is a paramount concern in polar climates, where strong winds and heavy snow loads are prevalent. Architects integrate aerodynamic features and employ robust construction techniques to enhance their shelter resilience against these environmental forces.
Technological strategies for polar shelters. Advanced technologies are crucial components of shelters designed for polar climates, addressing heating requirements and environmental sustainability. Geothermal heating systems leverage stable subsurface temperatures to provide a sustainable and energy-efficient source of warmth. This not only contributes to occupant comfort but also aligns with environmentally conscious practices in remote polar regions. The integration of double-glazed windows and high thermal mass material contributes to the overall insulations of the shelter. These architectural elements work in tandem with advanced heating technologies to create a habitable and energy-efficient environment. In summary, the combination of strategic architectural features and advanced technologies ensure that shelters in polar climates are resilient, energy efficient, and capable of providing secure and well insulated refuges for occupants.